So we are still working on topic 2.3. We are looking through the Explore 3 this time. So we're investigating reflections of function graphs. And the parameter in a stretch or compression is negative. Another transformation is called a reflection is introduced. Examining reflections will also tell you whether a function is an even function or an odd function. An even function is one for which when we plug in a negative x, we get the positive function back for all x in the domain of the function. Well, an odd function is one for which when you plug in a negative x into the function, you get a negative of the function back for all x in the domain of the function. A function is not necessarily even or odd, it can be neither. So first we're going to graph this where a is equal to -1, complete the input table, output table, and then graph it. In general, how is the graph related? Okay, so I am multiplying the output by -1. So -2 times -1 is 2. 2 times -1 is -2. -2 times -1 is 2. 2 times -1 is -2. So we're going to go ahead and plot that. So I've got -1, 2, -1, 2, 1, -2. 3, 2, and then 5, -2. Okay, you'll notice that if I were to flip on this line right here, if I was to flip, they would flip on top of each other. They're kind of like, they're not quite inversions, but they would be symmetric across that line. When that happens, we know what we have is called reflection. Like when you see yourself in the mirror, it's a reflection. So this is a mirror of each other here. So we would want to say that G of or the graph is a reflection, and you can say across the x-axis. All right. Now they're going to do this with the b of 1 in front. So let's look at that. So we're going to try to multiply by -1. So what do I multiply by -1 to get? I multiply 1 times -1, I get -1. I multiply -1 times -1, and I get 1. What do I multiply by to get +3? Well, it would have to be -3. What do I multiply -1 by to get net +5? It would have to be -5. So I'm going to plot this value with this value. So out 1 and down 2. Out -1 and up 2. Out -3, interesting, and down 2. And then out -5 and up 2. So my graph did something really weird. It looks like it shifted in a weird way. So this time I want you to look here. If I looked at that and I folded it and looked in the mirror like it was there, it's a reflection across the y-axis. So the graph reflects, or is a reflection across the y-axis. So if my value is outside the function, so this was outside the function, it went on the x. If it is inside the function, it reflects across the y-axis. Let's go ahead and look at these reflect questions really fast. So suppose a function f of x has a domain of x sub 1 and a range of y sub 1, y sub 2. When the graph of f is reflected across the x-axis, how do the domain and the range change? So across the x-axis, I don't think that the domain really changes, right? The domain stayed the same. The range actually ended up really staying the same. So it maybe went from, it maybe swapped it a little bit. It maybe went to the negative values, maybe. The negative y sub 2 to y sub 1. So instead of starting down here, it started up here. So we're going to write that down. So it was domain same. Range became negative y sub 2 to negative y sub 1. For a function, suppose the graph of f of x to the negative x is a reflection across the y-axis, identical to the graph of x. What does this tell you about f of x? Explain. Okay. So we notice that for a function, suppose that f of x negative x, the reflection of the graph across f of x across the y-axis is identical to the graph of f of x. So if I get something that is identical, okay, it's relating back up to here what we read here. If you have an even function, when you plug in a negative and you get the identical original function back. So it tells us that the function is even. It tells us that the function is even. Okay. Is the function of whose graph you reflected across from the axis in steps A and B an even function, an odd function, or neither? So, okay, so they're wanting us to say, so could it be even, odd, or neither? We're looking at this. So did we get the exact same function back either here, or the negative of it? I mean, we didn't get either one of those things. So this is actually an example of it being neither even nor odd. So it's neither even or odd because we never got original or negative original graph.